continuing. So for a complete circle, our theta has to equal the circumference over our radius, which is the same thing as saying, remember, circumference is 2 pi over r, and our radius is an r. So this is going to simplify down to 2 pi. So our full circle of theta has to equal 2 pi radians. Okay. In degrees, I hope we all know that to complete a circle, it is 360 degrees. So what this tells us is that 2 pi equals 360 degrees. So our 2 pi radians equals 360 degrees. And we can simplify, we divide by 2, and state that it is pi equal to 180 degrees. So 1 pi equals 180 degrees on our circle. This gives us some conversion factors for ratios, because now that we have pi over 180, we can see that pi over 180 or 180 over pi will help us convert from degrees or from radians. So this is what we're really learning today, and we need to know this conversion factor of pi over 180. Okay. So now we're going to look at some examples. Our first couple of examples are straightforward. We're converting to radians and to degrees. So to convert to radians, your answer needs to have pi in it. So we need to have pi in it and always on top. So we have 200 degrees. So what we do to convert to degrees to radians is we're going to multiply by pi over 180. So what you're going to do to completely convert, we do not want decibels. No decimals. Okay? So to do this, in your handy dandy calculator, do 200 divided by 180. We're leaving pi alone. When you do 200 divided by 180, you're going to then do fraction, our lovely math frac, all right? So you press the math button and then fraction. And you just see 200 divided by 180 is 10 nights, and our pi just stays on top. So to convert to radians, you take your original degree, divide it by 180, you press math frac, you're going to get 10 over 9, and then the pi stays on top. This is your radians. You're done. So once again, for negative 45, works the same way. We multiply by pi over 180. We're going to take negative 45 divided by 180, math frac, and you're going to see this is the same thing as negative 1 over 4, so 1/4. And again, pi just stays on top. You don't have to put the 1, so it's the same thing as negative pi over 4. That is it. That's all you have to do. Okay? So now that we've converted from degrees to radians, we're going to go from radians to degrees. So for radians to degrees, answer, I can spell, answer has no pi, should not have pi in it. So pi is now on the numerator. So to get rid of pi, we need to multiply by our conversion factor with the pi on the bottom. So that allows us to cancel out our pi's. So what you should do next is take 2 times 180 and divide by 3. And you're going to get 120 degrees. You should know that these should be rather pretty, so that'll be nice. But you canceled out your pi's, and you just multiply and divide. Okay? Same goes for 11 pi over 6. We're going to multiply by 180 over pi. Our pi's are going to cancel. 11 times 180 divided by 6 is going to equal 330 degrees. So again, just that lovely conversion factor of pi over 180 or 180 over pi. Okay? So when you want to go to radians, you should have a pi. When you want to go to degrees, there is no pi. So now we're gonna get into drawing angles in their standard position. So to do that, we need to first understand again that this is a representation of a circle, quadrant 1, 2, 3, and 4. And we should remember that a quadrant is 90 degrees, or, so if 180 degrees is 180 degrees is also pi, then a quadrant is half of pi. So pi over 2, okay? So this is just remembering quadrant is 90 degrees or pi over 2. That'll help us out in the long run. So we first start off with 350 degrees. So we start always on this one, so the right hand side, and we go counterclockwise. So we go 90 plus another 90, 180, plus another 90 is, I'm having trouble, 270. So we haven't even reached 300 yet. But if another 90 equals 360, we know 315 should be right in here. And this says, here is my angle. So what I need from you to do in drawing is you do start here, you go counterclockwise, and you make an angle, okay? So this indicates that you are at 315 degrees. You have to at least give me this. You don't have to give me this, but I need to see a circle and an arrow. So now we're at negative 500. So that changes how we do things. Since positive says counterclockwise, negative says clockwise. So we again start here, but since this is 500, that means we already have to go a full 360, because we're not even at 500 yet. We're going to add another 90, so 360 plus 90 is 360 plus 90, 45, 450, there we go. And then we add another 90, we go way over 500, so we know 500 is about in here, okay? So again, so we've noticed that 500 minus 360, we have 140 left, so we minus another 90, and we have about 50 left. So this is about 50 over here, and we make our standard angle just by doing that, okay? When in doubt, you can take your number and just go, all right, minus 90, minus 90, minus 90, minus 90, minus 90, until you get to something less than 90, and that's the quadrant you're going to be in. There is another way to do this one. Since this one is negative, there is obviously a positive. So to find its positive, you add 360, because it's a full circle, until you are no longer negative. And you're going to see this is at 220. Okay? So you add 360 until you are no longer negative. So I had to add it twice. I don't have to add any more. And so we're going to start, once again, on this line. We're going to go 90, 180. So that's 40 away, so that means there is a 40 degrees here, which indicates that our reference standard position angle is still in the exact same spot. We just did it a slightly different way. Okay. So that is standard angles with degrees, making sure you understand. All we have to do is just find where it belongs in which quadrant. As long as you were close, you're doing just fine. Now we're going to get into the nitty gritty. These are the ones that take a little bit more time, but I believe in you. You'll be great. So these are our radian ones, and this is where we see a little bit of trouble, but it's fine. You guys are great. So to do that, what we have to do and look at radians is we need to find pi or 2 pi in our given radians. The reason why is it'll help us determine where it is in the quadrant. So I have 5 pi over 4. Well, my denominator is 4, and I could get to 4 and 5, right? So what I mean by this is saying I can rewrite 5 pi over 4 as 4 pi over 4 plus a pi over 4. It's the exact same thing, correct? This allows me to see that 4 pi over 4 is the exact same thing as pi plus pi over 4. So this helps me in drawing my standard position. I can take and start here. 180 degrees is the same thing as pi. So I go 180 degrees, and then I need to add pi over 4. So this was our pi over 4, and this was our pi. And that gives us 5 pi over 4. So we need to break down the radians we have to the closest pi or 2 pi to help us get through in finding our standard position. So number 8, so this is one definitely that we need to look at. So we have negative 11 pi over 6. Is 11 over 6 closer to pi or 2 pi? That's what you have to think in your head. Well, if we think about 12 over 6 to being 2, it's closer to 2 pi. So we're going to see that this is the same thing as negative 12 pi over 6, because it's closest to negative 2 pi, same thing as negative 2 pi. We still need to get to 11. So that means we have to add a pi over 6, because that still equals negative 11 pi over 6. Now that I have that done, I now have a helpful reference. So I know I need to go negative 2 pi. And since it's negative, we go a full circle. So this is negative 2 pi. But we need to add to get to a negative 11 pi over 6. Add, so we go clockwise, pi over 6. So that means our reference angle is right there. Again, as long as you're in the correct quadrant and about the same thing, you are doing fine. It doesn't have to be perfect. But again, what you do when you look at your radians is, am I closer to pi or 2 pi? Break it apart, and you can standard your position. On 9, though, we have pi over 3. Well, pi over 3 is nowhere near pi or 2 pi, but it's really close to 0. And is pi over 3 less than pi? Remember, this is pi over 2. Our quadrant's pi over 2. Is pi over 3 less than pi over 2? It is. So that means we're just going to go pi over 3, and we're there. This one was rather just a, hey, you can be in between 0 and pi over 2, and pi over 3 is in this quadrant. Okay. And our last one for today, we have negative 3 pi over 2. 3 pi over 2, 3 over 2 is really close, so this one actually is perfectly halfway. So you can either go pi or 2 pi, but we're just going to go pi. So I can see that this is the same thing as negative 2 pi over 2 minus pi over 2, same thing, right? So this means it's negative pi minus pi over 2. I start over here, I go negative pi, so this is negative pi, and I'm going to see that this halfway point, pi over 2, is just right here. It's our standard position. So we have negative pi over 2, and we see that this is our standard position. If you have any questions, please let me know.